This video is going to provide us with an introduction to piecewise functions as well as increasing, decreasing, and constant graphs. A function that is defined by two or more equations over a specified domain is called a piecewise function. So here we have one, g of x. G of x equals x plus 5 if x is strictly less than -2, and it's x squared minus 6 when x is greater than or equal to -2. So we always actually look to the x first to determine which function we are going to use. So we look over here and see which category does the x value we're talking about fall in, and then we'll use the corresponding function to the left. So we want to find g of 0. So here we have an x value of 0, so we need to determine which of the two categories it falls into. X is less than -2. Zero is greater than or equal to -2, so we'll use the second function. Plugging it in, 0 squared minus 6. 0 minus 6, we get that g of 0 is equal to -6. Next, we want to find g of -6. -6 is less than -2, so we'll be using the function x plus 5. Plugging in, -6 plus 5. G of -6 is equal to -1. And now lastly, we want to find g of -5. Figuring out which category it falls in, -5 is also less than -2, so we'll be using our top function, x plus 5. -5 plus 5, we get that g of -5 is equal to 0. That's how we evaluate a piecewise function. So let's talk about intervals of increasing, decreasing, and constant behavior. A function is only defined as one of those three things. It's either increasing, decreasing, or constant. It's either going up, down, or it's perfectly horizontal. A function is increasing if its graph is rising from left to right. That is, that f of a is less than f of b when a is less than b. A function is decreasing if its graph is falling from left to right. That is, f of a is greater than f of b when a is less than b. And a function is constant if its graph remains the same from left to right. That is, f of a equals f of b when a is less than b. When identifying intervals that a graph is increasing, decreasing, or constant, you always want to use open intervals on the x value. And an open interval means that we're not including the endpoints. That's our change of direction point. We'll get into more detail in calculus about it, but for now, remember that you're always doing open intervals on the ends here. All right, so here we have two graphs. Let's determine the intervals where it's increasing, decreasing, or constant. Now, don't let the arrows fool you. Make sure that you're always looking left to right. So let's take a look at this first piece. It's going down from left to right. So that's going to be an interval that we're decreasing, and it started at -infinity with that arrow, and it's stopping at -3, and I'm using all parentheses here. The next portion of the graph, totally flat. It's horizontal. That portion is constant. So our constant interval is going to run from -3 to +1. And then the last part of our graph, it's going up from left to right, so that's increasing. Our interval that we're increasing is 1 to infinity. I frequently like to highlight the different portions just to make sure that I've hit everything. The first part of this graph, it begins by going up from left to right, so we're increasing till we get to this peak. That interval of increasing runs from negative infinity to -1. And then at -1 here, we've changed what we're doing, and now we're going down. We're decreasing from left to right until we get to this bottom here. So we're decreasing from -1 to +1. And then our graph changes what it's doing again. Now it's going up from left to right again. We're increasing another interval. So since we have a second piece of interval notation, of course, we'll put a union symbol in between 1 to infinity. This was constant nowhere.